Welcome everyone. So in this video we're going to look at practical illustration of some of the examples related to functions and function prototyping that we saw in the previous video. And so you have the square function example that you saw in the previous lecture on the lecture slides, that is typed up here. And so the first thing that we have is the function prototype, which tells the program that, or tells the compiler to expect a function named square. It will have an integer argument and it will return an integer value. So first let's just run this program to see that it gives us the right output. So we were expecting that what we're going to get is a square of the values of numbers or integers from 1 to 10. So first let's test it. Yes, so it gives you 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100, which is seems to be the right output. We have after the loop we just have the put string function, which is just added there to take you to the next line. So it's a simple program, but one of the useful things that you can learn from this, which you probably may not have seen before, or actually I know you haven't seen before, if you go into debug mode and then if you try to run this program, let's see what happens. So if I run the program, I go okay. If I press F10, so x is 1, I get printf, and I should be going into the square function, and when I press F10, what I actually get is printf returned 2. So what that means is printf, which basically calls square, so square basically returns, actually square should just be returning 1, so printf return 2 actually means something else here. But let's see what we got. So we just got the print of the square of 1, okay, which is also 1. Let's go back up. So we go back up now, x becomes 2. Again, if we run this, you see that square, so yeah, so down here you see that square returned 4, and so that 4 is basically printed by the printf function, which it is. And then if you press F10 one more time, you go back, now x is 3, now square should return 9, which it does, and printf basically prints that. So this printf returned 2. Now because printf is also a function, 2 means something else here, and we would probably have to look into the documentation of the printf function to figure out what 2 means here. But it's probably telling the program something like, okay, the printf function executed, or executed with a certain state or whatever. So let's not look at that for now. Now we may come back to it later, but the next thing that I want to show you is, now if you want to go in and see what actually happens inside the square function, you can do that in debug mode. So if you go back to this line where the square function is being called, you go to debug. On debug, notice that there is F10 basically corresponds to what is called step over. So step over basically means that if it is a command or a statement, you are just going to execute that statement without going into the details of this. But in this particular statement, we're actually calling 2 functions. In fact, we're going inside the square function first, and that is something which we actually want to go into, let's just say. In that case, you can use this um, feature which is called step into, and it comes into effect by pressing the F11 key. So let's do that and see what happens. So if we press F11, notice that we come down here to line 14. So F11 means step into, and step into means that you're going into the square function. Now you can press F10 and you see now you have a variable y. The value of y is 4, right? Y is actually a copy of x, and x was actually 4, so we get a value of y 4, and then we execute the next line and we should get y multiplied by y, which was 16. And so now we're at the end of the square function. If we press F10 one more time, we actually come back up here and we see that we have a square function returns 16. So we return 16, and then if we press F10 we go to line number 9. Then again we can execute this one more time. So if we press F10 we're back at this line. If we press F11 we will come down or step into the square function. Press F10, notice that y is now 5, so the square function will return 25, which it does, and then you can keep going this way, and then if you remove the debug point, your program executes and prints the right values that you want it to print. So yeah, so and another interesting feature or useful feature of the C debug mode that we discovered today, and that was step into. Now let's open another project. We also have a demo of the maximum function that we would like to look at. So let's look at this one. So this program basically asks the user to enter 3 numbers and then it prints the maximum of these 3 numbers. So let's quickly go through this program. First let's just run it one time. So let's just say we enter 55 to 9, and then it says maximum is 5. We can run it one more time. Let's just say we enter 1, 7, 5. Now the maximum is 7. So again we have this maximum function that we've defined here. It has this prototype which tells the program what the parameters are, what the function is going to return, and then we call the function, and that's how it operates. If you want to see how it works, well, you can kind of step into it first. Put maybe, actually this is probably a better location to put our breakpoint. Let's run the program. So F10, it will say, it will print enter 3 integers. You have to press F10 one more time for scanf to come into effect. So 3, 4, 9. Let's just say we enter this value. Now if we step into the maximum function, we see that we have 3 variables, x, y and z. Initially maximum or max is just some initial value. We want to set it to x, so we set it to 3. Then we check, is y greater than max? It is, so max becomes equal to y. Then we check, is z greater than max? It is, and then we set z to max to z, and then finally we return the max value, and that's how we kind of can repeat this process. Actually we don't have a loop here, so it just shows us max is 9. Okay, one more concept that I would like to illustrate here. Let me run this program one more time. So F10, let me just enter 1, 5, 4. Now notice in this program right now I have variables number 1, number 2 and number 3. If I step into my function maximum, notice that I do not see number 1, number 2 and number 3 because they are not visible here, right? What we see are variables x, y and z, which are local variables of the maximum function, and the variables that were actually inside the original main function are not visible here. What we see here are copies of those which we are calling x, y and z. So remember, you will have variables in the main function will not be visible to you here. You can execute the program once you return, and then when you come back, now you see that over here in the main function number 1, number 2 and number 3 are again visible to you, right? And so this is something that you want to remember. And then we can execute this. Right, and did it exit? It gave us the right answer, 154. Maximum is 5. One more concept. So now if I enter a decimal value instead of an integer value, so I entered 3.5, 5 and 9, the maximum value is 9. Let's see what the program does. It gives you maximum is 3. And why does it do that? Well, you can go into the debug mode and figure out why that happened. I leave that as a homework assignment that you can explore on your own. But notice that because the function expects integer arguments or integer parameters, and you're giving it a floating point value, and that's what's causing the problems. So that's why your program is doing something which you were not expecting. So remember to respect the arguments, or make sure that the users of your program also respect the arguments. So you may have to take some measures to ensure that this does not happen, or the user does not do something like this. We can look at these topics maybe later on at advanced stages of the course. So that's one concept. And another thing is, with the prototype, we've written that the function has arguments x, y and z. This is something which is not really required. So even if you got rid of these and you ran your program, it would still run fine. So 159, it runs correctly. So you don't have to give the names of the variables here because they're not really required. You will need to pass some arguments here, and you will need to maybe assign them some values here, but not in the prototype. Another thing is that a prototype, if you forget to write the prototype, you will get some error. So if your program compiles, it will say, well, some issue, and will say, well, I can't find, unable to open file, some sort of error. So it cannot, in the error it says maximum identifier not found. So you have to give the prototype. So this is something that C or new versions of C actually enforce now. So this is something that you must do and remember to do. All right. See you in the next video.